Hi everyone, I'm Maisha, the team leader of Team HawkEye. I think we will all agree in the recent years the weather has been extremely hot. In fact, the capital of our country, Dhaka, faced a temperature of 40.4 degrees Celsius in the month of April, which is the highest in 58 years. And it's not just about our country, many other countries around the world, especially the South Asian countries, are facing the adverse effects of climate change. And just when we are suffering, there is one insect for which this extreme weather is perfect for surviving. This is our enemy, the Aedes aegypti, famous for spreading dengue in 129 countries, affecting millions of people worldwide. Now let's see how dengue is related to climate change. Studies show that with increasing global temperature, the Aedes mosquitoes can now develop faster from eggs to adults, and the virus can replicate faster inside the mosquitoes. This means that more mosquitoes can become infectious and transmit the disease to humans in a shorter time. Another factor that connects dengue to the climate change is the heavy and unpredictable extension of rainy season. It is pretty evident that dengue is linked to rain, because Aedes mosquitoes need stagnant water to lay their eggs, which it can get abundant in rainy season.
Hello, I'm Asif Islam. Now we present to you the Aerial Warrior, a fully automated way to control dengue and save thousands of lives. You may have already heard of drones for dengue, and you may ask, what's the novelty here? Well, we have done some background study and we have found some major lackings. Our project not only contains any conventional drone, but the integration of full automation that does not require any ground control for object detection and actuation. The Aerial Warrior is an all-in-one project and has not been ever done before.
Hello, this is Sheikh Iftikhar Ahmed, and I'll be explaining the database collection of this kind of dengue-prone regions and image processing part of our project.
One of the important parts of a project is to successfully detect the possible mosquito breeding regions through image processing. For this purpose, we have collected more than 1,000 of pictures by ourselves. These pictures are collected from households and university campus, which includes possible stagnant water containers around our home and wet surfaces over the roads, fields, and ground. We have used an online platform roboflow.com to manually annotate all the pictures of a dataset. After the annotation, we have applied several transformations like random flip and random rotation on our dataset for augmentation. After augmenting, the total number of images for training is nearly 3,000. We used single state detection mobile net version 2 TF Lite model for object detection. This picture shows the architecture of the model. At first, we have built the model on TensorFlow. Then we have trained our model on our dataset for about 3 hours for about 300 epochs. After the training, we have converted our model into TensorFlow Lite version because the Lite version is lightweight and more compatible to use in a Raspberry Pi. The overall training result of our training model is average mean absolute precision is about 0.79, and the overall detection accuracy of possible breeding regions is about 82.33%, which is very good for our project.
Hello, I'm Onkun, and I will be explaining the hardware parts of this drone. This drone has quadcopter frame with 1500 kV VLDC motor. It is powered by 6000 mAh battery and a power bank to power the Raspberry Pi 4V to handle image processing. A relay-based circuit is deployed to operate DC pump. The heart of this drone is Pixel flight controller. There are also several basic components like GPS, telemetry, sonar, etc. Our drone is designed to operate in both manual and automatic mode. To operate in automatic mode, we can set the geofence or path by iRover or Mission Planner. This drone is operated by both Raspberry Pi and APM. After arming the drone, it takes off and flies within the selected region. Whenever a dengue-prone area is detected using image data, the Raspberry Pi sends the signal to down. Sonar helps to match the altitude. After matching the altitude, it dispenses a spray. After that, it again follows its BFAS path.
Our drone will save the GPS location of the detected dengue breeding object, and this data will be used to map dengue risk zones.
We are also planning to use BTI, also known as Bacillus thuringiensis, which will kill Aedes larvae but will not harm any human or other living being.
The total cost for this project is about 57k BDT or around 550 USD. The expensive components are the Raspberry Pi and Pixel flight controller. The frame and motors also contribute to a significant part of the total expense. We had to go through several trials and errors, but 20-30% of the cost can be reduced if produced in the industry. The model is scalable and we can scale it by accepting some trade-offs. Additionally, the Drone can also be used for various purposes other than controlling dengue, just by changing the deep learning model.
Let's see how this project actually works in real life. As you can see, we are in Raspberry OS environment. When the script is ran, the object detection mode is started. The drone can maintain low height as well as altitude up to 4 asteroid buildings. We also experimented it in low light condition. Though the accuracy decreases, but it's still quite good enough. After detecting the region of interest, it measures the altitude and displays the medicine. The control tree is still twitchy and we are still working on it.
Our project has a good market. From our country's perspective, some possible consumers would be our country's city corporation, and we have residential housing societies, autonomous corporation, and many others.
We thank you for giving us the opportunity of ideation and execution of such an effective idea. We are Team HawkEye.